So yes, machine learning is currently a very hot topic. It is a branch of artificial intelligence, and there is so much scope for its use in real world applications. Artificial intelligence can be broadly divided into two categories, as researchers divide. One is known as strong AI and weak AI. Some also called as broad AI and narrow AI. So, so broad AI or narrow AI. Still do not understand. So strong AI or broad AI. The understanding is um, that we are able to make a system which can almost emulate a human being. Yeah, a person has broad intelligence to learn from the natural surroundings and do many kinds of tasks. So scientists have been in that race to make strong AI for more than 6, 7 decades now. It's not a gradually everyone has realized that it's a very tough task. It's not such an easy task. They're heading towards it, but still, many top-notch scientists believe that we are still pretty far away from there. And then there is weak AI, where we focus on using AI methods, more specifically machine learning, to get our tasks done, like to make them more automated. So, for example, image recognition, or say fingerprint recognition, or any kind. So, like uh, many of the many of the phones, they have many of the phones these days they have face ID. They check their face and you can unlock your phone. And same is the case with fingerprint. So the understanding is that these can these can help make our lives easier and simpler. So and in such cases, machine learning is especially found to do very well. So until few decades ago, machine learning was not that popular. People would always prefer statistical methods. So in a way, machine learning can also be considered as an extension of statistics. So statistical models are more rigid. Rigid in the sense they have a lot of advantages with respect to their being more intuitive, and also they are more explainable. However, statistical methods cannot do so good on these daily many of the daily tasks. The reason being because they have very tight bounds. Statistics works with tight bounds. There is confidence intervals and tight bounds. Whereas in machine learning, we are not so much bothered about the bounds or confidence interval, but rather we are just interested in getting our task done. And in the hope when we are doing that, we also have some good understanding and good logic reasoning, somewhat intuitive understanding and reasoning to get our task done. It's not supposed to be a complete black box, but still it is very far away. In general, it is very far away from regular statistical methods with respect to their explainability. So now machine learning can be, as anyone can quickly do a Google search or go to Wikipedia, they'll find that machine learning again can be broadly divided into many categories. There's supervised learning, there's unsupervised learning, and then there is uh, semi-supervised learning, there is reinforcement learning, there is active learning. So today, in the next 25 to 30 minutes, I'm going to briefly discuss about each of these individual categories. So first, coming to unsupervised learning. Unsupervised learning is a task where we are just given a set of data and we want to learn patterns. We want to learn patterns or we want to make some understanding from it. So before we go ahead to understand unsupervised learning, semi-supervised learning, and supervised learning, it is very important that the basic understanding in machine learning is that all samples are assumed to be, so there is something known as data, and all those data samples are expected to be IID. Okay. So what does IID mean? Identically independently distributed. So for example, the understanding is like, for example, if we want to train our mobile phone for the face ID, so what we do is we generally take few samples. We click few images In phones, you generally are expected to turn your face in different directions so that the phone can take multiple images of a face and know how it will look in different angles. And then it tries to know which is your face compared to all other faces. So that is a very simple way, very simplistic way of understanding how Face ID works. So each of those images can be considered as a sample. Same is the case for fingerprint recognition. Each of those different tasks we touch, we give our fingerprint to our phone. These are like different samples. So the primary understanding is that there is some a box called generator. This generator creates the samples, and this generator is fixed. So those who have some idea of random processes or random sampling, so generally we in bachelor doing bachelor's degree, when I did my bachelor's in electronics and communications engineering, we learned about random processes, stochastic processes in my third year. So the understanding is there is a generator and it's like a distribution. All of you may be knowing Gaussian distribution, for example. So there is a common generator, there's a distribution, but samples can be from different places in the distribution. So if Gaussian distribution is like this, if it is something like this, it means that when you do random sampling, if you just take random samples, I'm not doing random sampling, I'm just getting samples from a generator which follows Gaussian distribution. If I take the histogram of the values, say for example, I have x-axis, I have the independent variable and a y-axis. I'm sorry, not the y-axis, sorry. This is the count. So to say I have x-axis and this generator is generating samples of single dimension points. If I take the histogram, like in MATLAB, we have the function hist, which gives the histogram. We'll generally find that the histogram will be something like this. So this is what is known as distribution. So though they are generated randomly, but the histogram count would be something like this. So in machine learning, we understand that there is a generator which has some inherent distribution which generates samples. And each of the samples are supposed to be independent of each other. So those who have some understanding of probability, we know, right? P of x comma y, if they are independent, is equal to P of x into P of y. That is provided if they are independent, right? And similarly, yeah, like for example, P of A given B. If A is independent of B, so it's not it doesn't matter. It is just P of A or the sorry. So they are independent of each other. The samples are independent of each other. It means one image is independent of the other image, and they are all identically coming from the same distribution. So this is the understanding. Okay. Now next comes, now I was talking about unsupervised learning. In unsupervised learning, we have some generator has already created these samples, and we are looking for patterns in that. Now, there may be many things that we may be interested in doing so. For example, we may be interested in finding clusters. Clusters means how are the samples grouped together. For example, if you just consider, you want to represent images of numbers. So those who are into machine learning, they will surely come across the very famous MNIST data, which is an image set of numbers, digits. It is used for digit recognition. It is, we hope and we have an intuitive understanding that now this MNIST data, it has a dimensionality of 780 some 28 cos 28. It has that dimensionality. Now, as we understand that two dimension is significantly bigger than one dimension. Similarly, the understanding is three dimension is much bigger compared and much what do you say, computationally expensive because there's greater freedom for where the point can lie. So three-dimensional is much bigger than two-dimensional. Now we can imagine if this is a 780 dimension space, really very huge. So there is a very famous machine learning scientist, Jeffrey Hinton. He says all people they when they talk of machine learning, they are talking of like plotting samples or visualizing samples in a higher dimensional space. And the way of how to visualize samples in higher dimensional spaces, You make a 3D space and then you loudly shout it is 4D or 5D. This is what most people do because it is so inconceivable, even for very trained people, to conceive of how samples they lie in the higher dimensional space. But as people, we want to visualize things easily in 2D space or 3D space. Now, say you have methods to reduce the dimensionality of that problem to smaller number of features, smaller dimension. So imagine I have a method, I have a function which takes higher dimensional information with a function to lower dimensional, right? So what will now say I have this function prepared where I transform the 780 dimensional images to a two-dimension image. So say I have this function which converts higher dimension to lower dimension. Then what will happen is I want to transform the images to two-dimensional image. So what will I hope? Numbers like 1 would be in one area, 2 would be in another area, 3 would be in another area, 4 images of 4 would be in another area, right? This is what we will intuitively hope. But this is not what happens actually. But this is what we hope. Now say I do not know that these images belong to 1, 2, 3. So how do I know? And I want to look for groupings. So that is where unsupervised learning comes. Because you do not have any information, you only have data and you want to look for patterns. Similarly, another task of unsupervised learning is to know, to guess what the generator could be. How can the generator be modeled? So say I only have samples everywhere and I want to know by non-trivial means how the generator may be, how the generator is modeled. So this is unsupervised learning. Okay. So learning the distributions. And also another way of unsupervised learning is dimensionality reduction, right? For example, this function we were talking of converting from higher dimension to lower dimension, because we want to always visualize something in very high dimension in lower dimension so that we can visualize better. So this function also of how you can best convert from high dimension to lower dimension is also another way, is another form of unsupervised learning. Okay. Now this ends unsupervised learning. Now coming to the next point, that is supervised learning, which is one of the supervised learning and unsupervised learning are one of the biggest areas where a lot of research has been done since decades. Now coming to supervised learning is simple. The understanding is you have some given input X and we know that the corresponding output is Y. Now I want to know the mapping from X to Y. What is this mapping and what is the best way to map? This is what is known as supervised learning. Now, I think these tasks are not so difficult. They may be very trivial, right? Now, I can show you an example I can explain to you how it is not trivial. So this mapping, right? This mapping, it can be two ways. There are two ways of how this mapping could be done. If Y is categorical variable, for example, say we have a face recognition system which takes our image and it says, okay, is it me or is it my friend who is staying with me? So then what will happen is I take few images of myself and tell, okay, these photos belong to, say, my name Rahul, and say then I take photos of my friend and I clearly mention that these photos are of my friend. So now this face recognition system will try to best divide amongst Rahul and friend. Now you see in unsupervised learning, say I did not have this information of which photos are of Rahul and which images of a friend. What I would get is maybe I'll get some images maybe very close by. And because you do not have any information, it may not do perfect distinction, but it may be able to find groups. Okay, I think images of Rahul, they kind of form some group, they are close to one place because these images have come from Rahul, which is like a one generator. I mean, so they'll be different, and same is the case with friend. So this mapping, we are trying to learn the mapping. Now, if Y is categorical variable, we say it is classification, and if it is continuous variable, it is called regression. Now let us consider this task. Okay, I have, say,
image of Rahul, which I, using a function, I transform it to two-dimensional point and say this is the image. These are the samples which basically I'm trying to represent the images of my friend. Now the question is, how do I identify? How can I discriminate? A simple way would be one may say, oh, I can easily see these points on a two-dimensional line, two-dimensional space. Let me just draw a line. So anything which is on the right is the images of friend, which is on the left is that of mine. So one may think, okay, this is a very trivial problem. But now this is one of the very simplest of all problems. But now the question is, which line is the best line? Line could have been here also, line could have been here also, line could have been, no one says that the line has to be straight. It could be like this also. Anything inside the circle is image of the friend. Anything outside of this circle is image of Rahul. But say tomorrow a third image comes, third person comes. Now his image could be here. Say it is somewhere here. So like then one may ask, then how do I draw lines? How do I make sure the distinction so that my performance, we want the image recognition performance to be perfect, as good as possible. So that is why this is how the gradually this problem can become complicated, because there can be infinite solutions. The question is, now you try to find out which solution is the best. Now we just not talked about how there can be infinite solutions for this. Now consider this, those who study about random processes and infinite numbers, they will understand that the real numbers in three-dimensional space is much bigger. The infinity of 3D real numbers, three-dimensional real number vectors, is bigger than the infinity of real numbers in 2D. Now consider a machine learning problem, a supervised learning problem where the dimensional is 700,000, 10,000, 100,000. Now I hope you will be able to understand that how big the infinity would be. We are talking of discrimination between infinities, and each higher dimensional we add, the size of infinity, that infinity is bigger than the size of infinity of the smaller space. So finding the best solution among those infinite solution is not a trivial problem. It can be, it's a problem which researchers have been trying to find, and already they have made really good progress, because that is how even human beings work, right? Every image we get when we see our friends, we do not see our friends many times. We may not have seen our friend many times, but still we may be able to recognize his image, even though he may be standing backwards or sideways, still we are able to recognize. So this is supervised learning. Now similarly, now there's in our 12th standard, in our 11, in our high school, we would have heard of polynomial regression and fitting a polynomial in a point. So similarly, now consider I have this numbers. Okay, I have samples where x is my independent variable, y is my dependent variable. Now I plot these samples and I say which is the best line which fits this. We know that if we have to use a single dimensional line, that is with 2D, with only with only two variables, that is weight and bias, we may think, okay, this is the best way. If we increase our polynomial order, things may come like this, and probably this is what we want. And someone may say, no, this solution is best. Someone may say, oh, even this solution is there, right? This also is going to fit all the points. Then what is the problem in getting one? How do we discriminate which infinity solution, which of the infinite solution is better? Because all of them will be able to fit the points perfectly. So this is again where supervised learning comes. How to make sure that it is simultaneously flexible enough to fit the points, but we also understand that these points may have inherent noise. So we don't want to make it so flexible that you get this kind of jittery kind of a curve, which we believe is not actually fitting the points, but it is actually capturing noise. So this is supervised learning problem. Now that we are done with the supervised learning and unsupervised learning, let us quickly move to, I'm going to show two Python codes of supervised learning, an example of supervised learning and unsupervised learning. Now let us move to the task of semi-supervised learning. So in semi-supervised learning, the understanding is, okay, so now let us change to a problem of spam email detection. All the emails with the Gmail or which are emails we use, Yahoo email or Outlook. We know that there is something, the email system automatically identifies which email is spam and which is not. Okay. Now, all of us can try to think, how can I identify if this email is spam or not spam? So one way would be just like how we did email image recognition. All of us could have thought, okay, let us do this thing. Let me take a person, let's say let me take some emails. Let me take emails of Rahul, and let me again try to, now we should understand this is not images, this is text. And text is, how will you represent text in numbers? It's a big problem. This itself is a very big question or problem to be addressed. There is something known as word vector representations, which all of you can try to search. There are so many ways of how you can actually represent words as numbers, and still those numbers mean something. Because like in categorical variables, these are not like regular real numbers. In categorical also you have two types of categorical numbers. One is called ordinal numbers, and another is nominal kind of categories. Ordinal categories is something like which we get whenever, say, we get something from, say, Amazon or Flipkart or whatever. They will say, okay, how happy were you with our performance? Please rate us from 1 to 10. So here 1, 2, 3, 4, 5 till 10, these have some meaning. There is some order in them and they have a meaning. So they are called as ordinal numbers. But also sometimes you'll find you may find that there are other kind of categories which are nominal. So for example, gender, male and female, there is no such thing as ordering. You cannot order them. That will be inherently wrong. So the same is the case with text. How to, you cannot treat text as ordinal numbers because there is no such thing as ordering them. So how can we best? But simultaneously, we also understand that these texts, they are not fully independent of each other because there is some syntactic and semantic and syntactic context. Syntactic is the grammar context. For example, in the language of English, when you speak something, you follow some grammar. And coming to the semantic is like the relationships between words. For example, now when you say king, it inherently has the understanding that king is most like is going to be the male, is a male person, because if it is female, you will address the same title as a female, right? So now, here we have understood. So king is male and queen is female. This understanding is inherent. But if we treat them as nominal variables, as if they are independent of each other, that will be again wrong. So how can we actually assimilate all these the interrelationships between words, uh, interrelationship between words, which includes the semantic and syntactic context, so that it can understand our emails and then best determine if this is spam or not spam, or if this email is something very urgent or if it is not urgent. This is a big problem which scientists who work in natural language processing and machine learning, they work upon. And as we get into these details, we understand that how each concept is so important, because one can we were talking about spam email detection. Now I could have made the spam email detection in very simple way. I can do one thing is like add, just search for the word add. If there is a word like add, or if there are a lot of images, there are a lot of HTML links, then let me flag this as a spam. Okay, so I can make such rule based systems. But the big question is, will this rule based system really work every time? Because people who send us advertisements of spam, they are smart enough to know how the rule based systems work. So they'll make sure to not use the word add, but they will use some other words. So when you get into this competition of how to make sure that the spam email detection happens perfectly, that is where it is good to know the inherent understanding of how words, they relate to each other, what the meaning of the paragraph means, what the email means, what the images mean. So that is where things become more complex and they become very interesting. And that's how it's a very interesting topic as well. It has a lot of mathematical basis, and simultaneously it's very intuitive and logical. So we were talking of spam email detection. Now the big question is, one, how will I? We were talking of how to do image recognition by taking images of myself and my friend, and then I label them. Then I label them that this is of my friend and this is of my myself. Now, can I do the same thing with spam email? Yeah, I can do that to some degree. But the question is, how many emails will I do? Because I may not have the capacity to annotate all of them. I do not have the capacity to annotate all of them, right? So Because how many will you do? Tens, hundreds, thousands, 10,000. How many will you do? There is no limit, because always there will be some new email which may come which I may not have labeled. So as we study machine learning, we'll understand that the biggest expense in more public in complicated machine learning problems is the annotations. For example, I work here at Harvard Medical School and Massachusetts General Hospital. I work with ICU patient data, especially with arrhythmias, cardiac arrhythmias. It We understand, especially in the United States and even back in India, we understand doctors, physicians, they are very busy. Now I cannot sit and annotate recordings because I'm not medically fully trained. I didn't do my MD. So we want to take help of those who have already done their MDs, and certainly they can do better annotation of whether the person is healthy or deceased, and what disease, what degree of disease, which rhythm in ECG, what rhythm in blood pressure, what rhythm in PPG, right? We need help of doctors. Now I cannot ask doctor to just leave his business of treating patients, because that is like of primarily most important. So the physicians cannot leave their job. They have very less time, and we cannot demand them that they just stop treating patients and just keep annotating data so that we can make good machine learning systems which we can use in medicine, right? So this we'll understand that annotation is very tough. So semi-supervised learning means I have some annotations. I have some annotations of saying that these emails are what we say. There are emails which are spam and there are emails which are not spam. In addition to that, I also have huge corpus of email, which is not. It is very easy to get corpus of email. There may be many people who may be happy to share the corpus of email without annotating. So how can I actually use the understanding of language? So if I just use annotations, it is supervised learning. If I take also advantage of the emails which are not annotated and use that knowledge to learn the uh, relationships, and this after, so there is, you learn relationships with this huge corpus which is unannotated, and then you try to assist the supervised learning problem. This is known as semi-supervised learning, where the number of annotations are few, but you have so much unlabeled data without the mapping of why. But you are smart, so you want to take the best advantage of all the resources we have. So we also try to make out methods where I also take advantages of that data which is annotated and that data which is not annotated, but it has very important information about how the data is, what are the relationships between data, and I make them to assist the problem of supervised learning and make it better. That is known as semi-supervised learning. I hope this is clear. So say, for example, you have spam email, maybe 3-4 samples, and you know which is not spam by this. Okay. And then you have huge millions and millions and millions of unannotated data. So we are taking advantage of this data to better make the discrimination in semi-supervised learning. So I'm talking of distinction, but obviously supervised also includes regression. So you can also do it for regression, fitting a distribution or fitting a curve on data. So now we are done with semi-supervised learning. Fourth comes active learning. Now what is active learning? Active learning can be considered as a further extension of this problem. We just now discussed that annotations is something very expensive, but more the annotations, better will be our performance. For example, more the images I take or more the emails I annotate as spam and not spam, better will be my performance of discrimination, whether this is spam or not spam, or the image of my friend or not my friend, right? So the better is the advantage, right? Better is this whole what we say uh, task. Now the question is, if we want to increase annotations, I want to be smart in identifying which data to annotate. So which data should I annotate? That is, say I have 1 million samples and I have been able to annotate 100 samples. Now, say I have money to give to a doctor or give to a person who's annotating. I'm ready to give him money, and I'm going to ask him to annotate a record. So that person will ask, okay, tell me which sample should I record? Now, I want to make the best use of my money, right? So that's why I want to be smart in choosing which next sample should I annotate. Now, example, I may say I can annotate this one, which has not been annotated. But I would say, see, this is very close to these circles. So it is very likely this may not be so useful to me. what sample may be more useful for me in annotation? Maybe this sample, because it is in between of my distinction. Say, so if this is star, I may shift my boundary to like this. But if this is circle, I would shift it to something like this. So I hope you're getting the point. So which next sample should I annotate? That is what is known as active learning. And finally, there is reinforcement learning, which is very popularly used these days. Reinforcement learning is a case where you have something like rewards. There's a concept of rewards and give and take. So you basically, you are in a process where you only know at the very end whether you did something right or wrong. For example, solving a maze. If you want to solve the maze, you only know if your method was correct if you reach the destination. Until then, you do not know. Similarly, if you want a robotic arm to go and catch a mug of, say, a jug, you want to carry a jug. So like similarly, if we have a robotic arm to catch a jug of water, now unless you actually carry it perfectly, hold it, all other tasks are considered failure. Similarly, in many games, like we heard that Google, the deep learning team, they were able to beat this AlphaGo champion. They were able to defeat. So so this is, I'm talking of a supervised learning problem. So there is a very popular data called as IRIS data, which is a 4-dimensional problem. And there were 3 classes. So the data will look. I hope you can see the example of discriminating 2 faces of my friend and faces of mine. So this is a case where they actually try to characterize 2 different flower types of iris. So, and they are trying to represent by its petal width, sepal length, petal length. So this is like the length and width of the different petals. And they are one is trying to identify if this petal belongs to that of iris, virginica, versicolor, like that. Different forms of iris. So this is how it will look if I represent. This is a 4-dimensional data, but I'm only using the 2 dimensions so that we can visualize in a 2D. Now there is a popular method called a support vector machine, linear support vector machine. Now I'm going to try to identify the line which can actually categorize these two as left and right, and so that I can use this line so that anytime in the future, if I get a sample which tells the sepal length and petal width and all these features, if I get a problem, I will be able to discriminate if this. I can automate the process of discrimination, which kind of iris flower it is. And as I was talking, the infinite solutions. So linear support vector machine tries to find a linear hyperplane which can discriminate the 2 classes with maximum margin. I'll not get into details. So here we train a classifier to Python. Now what are the weights? So weights are going to be, this is going to be the weights and bias. So just like we have these parameters to characterize weight and bias. Now if I plot this, so I get a line, right? Now you'll find that this line is actually misclassifying the blue point, right? Because all points are on the left are blue, but this one point is left. So why is this so? Now you'll understand that there are many ways of how I can make these changes. Now if I make this, there is something known as cost. So how do you treat these problems is by actually formulating them as a mathematical problem with some objective functions, and then you use optimization methods to get your solution. Now you'll find that if I make this C is equal to 1000, this line will change. So machine learning is actually, in supervised learning, it's a different problem. Now you'll find that the line has changed. Now what if I make this very huge? It is trying to have as less error as possible. Now when I make the cost very high, that you may penalize it as less as possible, then the line is perfectly classifying. But we should understand, it is possible that this point could also have been a noisy point. So we don't want to make a solution which perfectly fits all points and giving us 100% performance on training data. We want a solution which is very general, which gives a good idea. So that's why we will not necessarily use this, but what we may use is maybe a less cost. So how do I decide that cost is again a problem which all of us can work on. Similarly, k-means clustering is a problem. It's an unsupervised learning problem where you're trying to find the groups. Now I'm going to plot this data. We do not have any labels. Okay. Now when I see this data, what do I think? All of this, I do not have any mapping as to what these individual points mean. So what do I think? I think that maybe, okay, I intuitively feel that these points belong to one group, these points belong to one group, these points belong to one group. But the question is, I can visualize this in a 2D space and I can say this, but how will I do this in a 10,000 dimensional space? It's inconceivable for us. So we have something known as clustering methods. I'm just going to run the most basic of all clustering methods. This is known as k-means clustering, which is k-means clustering. Just give me a minute. Okay. Okay. So I have written these functions. This, in case any one of you wish to have this code, I'm happy to share this code. Now, what will I do is I try to know what are the groups, inherent groups. Now, X is my training data, which I just plotted here earlier. Now, I use methods, automated methods by trying to know. Now, I do not know how many groups are actually there. How will it look if I say only two groups? So it is grouping these two things, these two groups as a single group and this point as another group. Now, if I make this 3, it has not done perfect distribution. So because the initialization is random. But if I do it once again, you'll find that it is doing perfect. So there are again methods by which you get a more better solution. Like there is expectation maximization method where you'll always get the correct solution. But the point is, how do I know how many groups are there? That itself is again a problem of it's a problem to be addressed. Sometimes you have some insight, some expert knowledge, because someone who knows the system already has some insight. They may tell us how many groups are there. So how can I best do the discrimination and all? That is something uh, I want to know. So this is k-means method. This is again an unsupervised method where I'm trying to identify groups without anyone telling me what the labels are. Now I did clustering with 4 labels. So I'll end my presentation here. I hope those who are new to machine learning could get some help. I hope it was some help to some people. If that is done, I will consider my presentation successful. At least even if the knowledge part is increased by 1%, also that's good. Thank you very much.